hard. Like, I don't know. You guys are on today. So, yes. So we already covered by graphing by substitution. Today we're covering by elimination. If you notice on the board, it should say by elimination. So let's see where we're at. We solved systems of linear equations where we did by graphing, by substitution, and today we're covering something called elimination, also known as combination, also known as addition. So these are the three different methods that we're going to learn to solve systems. So we don't need a Freire model because we already have the Freire model for systems. We already know what they are, but we do need steps. So our objective for today, I can solve system of linear equations by elimination. Let's read together. 1, 2, 3. I can solve systems of linear equation by elimination. So copy these steps, please. Since we don't need a Freire model, we know that systems are two or more linear equations, same variable. Step 1, change all equations to standard form. Step 2, eliminate one variable by adding or combining. Step 3, solve the equation for the remaining variable. Step 4, substitute the value of the known variable to one of the equations and solve for the last. Write as a coordinate and check. Copy that, please. So, step 1, keyword here is change. And what are we going to change the equations to what? Standard form. Step 2, keyword here is eliminate. What are we going to eliminate? One of the variables. Step 3 through 5 is the same as yesterday, if you noticed. We solve the equation for the remaining variable, substitute that value into one of the equations, and solve for the last variable. And at the end, we're going to write our coordinate and check. Is that correct? So does everybody agree that the last 3 steps are what we did yesterday? Just the first 2 steps is something that's new that we need to apply for elimination. So once again, since we're getting to multi-steps, just to remember our steps, the sign that I use for change is like this. Bam. So what is it? Step 1, change into standard form. Step 2, eliminate. Eliminate one of the variables. Step 3, solve for the remainder. Step 4, substitute, solve for the remainder. And then at the end, write and check. Write your coordinate and check. Are we there? So once again, step 1, change into money. Change into standard form. Step 2, eliminate one of the variables. From there, solve for the remainder. Step 4, substitute that value into one of the equations and solve. And at the end, write your coordinate and check. Now, in case you forgot standard form, write it right next to that or above where it says standard form. AX plus BY equals C. Does everybody see that?
Why? You see what I mean? Why? AX plus. Oh, yeah, I get it.
All right. So what do you notice about standard form? If I draw the line down the equal sign, that both variables are on the same side, X and Y. X comes first, then Y. Are we there? All right, so let's get started. Once again, if some of you have 100 font, or if you're writing with your feet, do it in the back. If not, you have space for one problem underneath those steps. Copy this. Example 1, solve systems of equations. And they give us a system y equals negative 2x minus 5 and y equals 2x plus 13. Copy that, and I'm going to go over the first steps, and then I'll have you copy. All right. Pens down, eyes up here. Here it goes. So, according to our steps, our first step is what?
Change.
Change into standard form, which means, look at these. Are these in standard form? No, they're solved for y. They're in slope-intercept form. So I'm going to write them side by side, and I'm going to solve for standard form. So what do I do here, everyone?
You substitute. Oh, wait. No.
Add 2x to each side. So I'm left with 2x plus y equals negative 5. So what do I do here? No. subtract 2x. Subtract 2x to each side, and we're left with negative 2x plus y equals 13. Copy that, please. And those are standard form.
Oh, wait, Mr. Q, does it matter which number is the leading coefficient for the x?
X has to come first.
So that'll make the negative 2 the 8.
Yes. Copy that, please. Here we go. So step 1 was to change it into standard form. Did we do that? Okay. Next, what I'm going to do, focus, please. I'm going to rewrite these two, one on top of the other. Over here. So I have 2x plus y equals negative 5 and negative 2x plus y equals 13. Don't copy this yet, just pay attention. I'm going to the next step. Eliminate one of the variables by adding or combining. Check this out. Do you see it now? For those of you that don't see it, we're going to combine these two together. So what is 2x minus 2x? What is y plus y? What is 13 minus 5? Copy that, please. Let me recap the process. Step 1, change into standard form. Did we do that? Yes. Step 2, eliminate one of the variables by combining. Yes. Step 3, what does step 3 say? Solve the equation for the remaining variable. Can we solve this? Yes, so go ahead and do that. We divide by 2 on both sides, so therefore y equals 4. And the rest is the same as yesterday. You should be able to finish it off by yourself, but I'm going to walk you through it. Step 4, substitute this into one of the two equations. Which one do you want me to use? The top one? So I'm going to use the top one, 2x plus y equals negative 5, but instead of y, I'm going to substitute in there the 4. So this becomes 2x plus 4 equals negative 5, and all I have to do is solve for the remaining variable. So what do? Minus 4, we got 2x equals negative 9. Divide by 2. X equals negative 4.5. Now, did anybody catch that the last step said, thank you, Edgar, raffle ticket, don't forget it. Here you go. Did everybody catch that the last step, I wrote write as a coordinate and check? Hold on. So let's write it as a coordinate. What is our coordinate? Negative 4.5 and 4. All right? So to check, I don't know if you notice on the steps I gave you, it said check one equation. But that's just for right now. But we know we need to check for both. Is that correct? So for the purpose of today, just to get plenty of practice with this, we're only going to check one equation so that we see exactly what we're going to do, right? So let's check. To check, I'm going to check using the first equation, which is 2x plus y equals negative 5. So instead of x, what goes there? Negative 4.5. Instead of y, 4. So we get 2 times negative 4.5 plus 4. So this becomes negative 9 plus 4 equals negative 5. Is negative 5 equal to negative 5? Yep. Boom. That just happened. So we know that we need to check both equations. Is that correct? But for right now, we're going to move on so we can get another equation and we can practice another system. So the process, standard form, eliminate one of the variables, solve for the remainder, substitute that into one of the two, solve for the other variable, write as a coordinate, and check. We got it? All right. Example number 2. Copy this one, please. What happened to the other? Hold on. Hold on, let me... All right, let's move on. Here we go. Write this down. Example Example 2. One of them is y equals 4x plus 2. Yeah, see if you can do this one by yourself. So, step 1, change it to standard form. From there, you know what to do. Copy and solve. Go. I'll give you a head start. So the step from here, change it to standard form. It looks something like this. And you end up with 4x plus y equals 10 and negative 4x plus y equals 2. Is that correct?
Yes.
From there, we eliminate the x. We're left with 2y equals 12. Solve for y equals 6. Is that correct? Substitute that into one of the two. I'm going to substitute into the top one. Subtract 6 from each side. We're left with 4x equals 4. Divide by 4. X equals 1.
What?
Oh, okay, never mind. Okay.
So my solution, possible solution is 1, 6. Let's check. So instead of x, I write in there 1. Instead of y, 6. 4 times 1 is 4. 4 plus 6 is 10. 10 equals 10. Everybody got it? You able to get the idea already?
Yeah.
Okay, let's do another. Yes.
So, can this only be done when there's number and it's opposite?
We'll get there. Yeah, we'll get there. Yes.
Do you have to check it when you put it in standard form, or can you do it like teaching how it was?
You can check it how it was, yeah. All right, here we go. Copy this one. Example 3. X equals negative 2y plus 11 and negative x plus 4y equals 1. There's a system. Solve, please. Copy and go. Shouldn't take you more than 1 minute. Go. See what we got. So, this one's already in standard form. So this one we should do what? Add 2y, add 2y. We end up with x plus 2y equals 11. Is that correct?
Yes.
So we put that one here. X plus 2y equals 11. We're left with 6y equals 12. Divide by 6. Y equals 2. Substitute into one of these. I'm going to use the second one so I don't deal with that negative. X plus 2 times 2 equals 11. X plus 4 equals 11. Minus 4, x equals 7. So my solution to the system is 7, 2. Hands, have you got that by yourself? Okay.
I switched them. When you have the...
Yeah, don't switch them. Standard form. X comes first, then Y.
Oh, when you line them up?
Yes. Here we go. Example 4. Copy this one. X plus negative, x equals negative 3y plus 8, and negative x plus 5y equals 8. Copy that and solve. I'll give you a minute. Ready, go. Answer. What'd you get for your answer, Seabass? 2.
What? What kind of is that?
Oh, my bad. 2. Hands, we got 2. That is correct. All right. Let's go to number 5. Okay, there it is. Y equals negative x plus 4 and 3x minus y equals 3. This is the last one of these simple ones, so we can move on to funner stuff. Copy that and solve. Once again, I'll give you guys 1 minuto. Go. Okay, check with the neighbor, see what they got. Okay, let's see. Help me out on this one. Edgar, what'd you get for your solution? $1.75, 2.25. Hands if you got that, or 1 3/4, comma 2 1/4. Either one is correct. That is correct. Solution. If you don't see it, here we go. This one, to change it in standard form, we add x to each side. We end up with x plus y equals 4. Eliminate 4x equals 7. Divide by 4. And that's how we get x equals 1 3/4. Yes? And then you substitute and solve for the other. All right. Let's move on to better things. Copy this. Example 6. 3x plus 4y equals 18, and negative 2x plus 4y equals 8. Just copy that. I'll walk you through the first step. All right. Pens down, eyes up here. Here we go. Focus. Eyes on the screen. So according to our steps, step 1 says change into standard form. And what do you notice? They're already in standard form. Step 2 says eliminate one of the variables. So I stacked them. I'm going to eliminate one of the variables. So let's see. This becomes x. Wait a minute. This becomes 8y. This becomes 26. None of them eliminate. Therefore, pay attention, please. We have a dilemma, but it's a simple fix. Look up. Which one would you eliminate if something happened to it? Which variable? The y. One of them has to be a negative, which means that in order to make one of these a negative, we need to multiply the entire equation times what? Negative 1. Does it matter which? Does it matter which? No, as long as one of them is a negative. I'm going to do the top one. Check this out. Times negative 1. This becomes, I'm going to write it down here, negative 3x minus 4y equals to negative 18. And now I no longer use this, and I use this. Copy that, please, and solve.
That's cool.
You know what to do from there, right? Finish it off, please. Go. Copy and solve. All right. Let's see. At this point, we can eliminate the y. Is that correct? We're left with negative 5x equals negative 10. Divide by negative 5. X equals 2. So far, so good. Then substitute that into one of the two. I'm going to take the top one, negative 2 times 2 plus 4y equals 8. This becomes negative 4 plus 4y equals 8 plus 4 plus 4. 4y equals 12. Divide by 4. Y equals 3. Therefore, our solution is 2, 3. Michael Jordan. You guys see that? 2, 3. Yeah. Wow. All right. Any questions with these? Okay. So let me go back to the original. Guys, focus. Let me go back to the original one. When we have something like this, where we cannot eliminate one or the other, we need to transform one of the equations where the coefficient of one of the variables is the opposite. Is that correct? Listen to what I just said, because I'm going to give you one that has a little slider and see if you pick it up. Here it goes again. Whenever you end up with a system that cannot eliminate, you need to transform one of the equations so that one of the coefficients of one variable is the opposite of the other. You ever understand that?
Yes, Mr. Q.
All right. Copy this next one, please. Yes.
Can we ever get to the point where there are no same coefficients?
Copy that.
Wait, what? Wait, what you say, Julia?
She said copy number 7. And see if you can do that one by yourself. Example number 7, I'm going to give you a head start. That's why I asked you to pay attention to what I just said on the previous one, right? Copy that and see if you can solve that by yourself. Go. Step 1, both of them have to be in standard form. Are they in standard form? Yes. Step 2 was to eliminate one of the variables. So I'm going to try and combine these, but we see that we cannot eliminate either one. Is that correct? Focus, please. Now, the dilemma here is that none of them have the same coefficient. But does a variable have the opposite sign of the other? Which variable has the opposite sign? Therefore, what can I do to this equation? Everyone? Multiply by 2. Everybody see that? Okay, hold on. Now,
I don't understand.
hold on. In order for me to eliminate x, this has to be what?
Oh,
Negative 2x. It's already negative. All I have to do is multiply times 2. Is that correct? Now, look what I'm going to do next. Let's say we didn't start with x. Let's say we wanted to eliminate y. What do I need to do? Think about it. Don't say it out loud. Think about it. What do I need to do to eliminate y?
The top one.
The top one times what? Times negative 3. Does everybody see that? So what is the key? You need to transform it so that one of the variables has the opposite coefficient. Does that make sense? All right, home plate for tonight is found on pages 300 and 302 only. And, not through. Have a good one, guys. They're shooting today. If I don't see you guy tomorrow. Bye.